Good morning. So in today's lecture we'll talk about hypothesis testing, but in this hypothesis testing we'll talk about two sample inference. So the idea here is that you have two different samples from two different populations, and we want to see whether the conditions are the same or different. So this is the primary understanding in the hypothesis testing when it comes to two sample inference. So in this we're going to talk about specific tests called paired t-test and two sample t-test with independent samples with equal variance, and we'll also talk about how to find the sample size and the power. So let's talk about two sample hypothesis problem. So in a two sample hypothesis problem, the underlying parameters of the two different populations, so we do not know both of them, and we are assuming that we do not know both of them and we are trying to compare them. So let's take a simple example. If you take an example of hypertension, let's say we are interested in the relationship between how oral contraceptives affect the blood pressure in women. So let's consider two experimental designs that can be used to assess these relationships. So there are two different methods that are involved. One is called as a longitudinal study. So the name itself says that it's longitudinal. So the other name for longitudinal study is a follow-up study. So where we see and follow the samples over a period of time. So in this case of hypertension, OC users and women, in terms of hypertension, so we identify a non-pregnant premenopausal woman of childbearing age 16 to 49 who are not OC users, and we try to measure their blood pressure. This blood pressure that we measure initially is called as the baseline blood pressure. So whenever you say the baseline, it's the initial value or the base value. So what we do then is we rescreen these women 1 year later, and to ascertain a subgroup, so who have remained non-pregnant throughout the year and have become OC users. So this is the subgroup, is the study population. So this subgroup is our study population. So what we do next is we measure the blood pressure of the study population at the follow-up visit. So in the next case, what we do is we have the baseline value and we have the follow-up value, and we try to compare both of them and see if there is any changes. So if there is no changes, then we say that OC does not affect the blood pressure in women. If there is a change, then they say that in the sample OC affects women. So this is the idea behind a longitudinal study. So in a longitudinal study or a follow-up study, so we consider the same group of people over a certain period of time. So this is the main idea behind a longitudinal study. The other type of study is a cross-sectional study. So the primary characteristic of a cross-sectional study is that the samples are only seen once. So which means that you do not repeat the study, or you do not see them twice, you do not see them 3 times, you do not see them 4 times, a number of times. So here in a cross-sectional study, we identify a group of OC users and we identify a group of non-oral contraceptive users, and both of them are non-pregnant premenopausal women. The reason is to make sure that we do not have any bias, and we take up the same age group and we measure the blood pressure, and we compare the blood pressure level between the people who use oral contraceptives and people who do not use oral contraceptives. So that's the reason why in a cross-sectional study, so we only see the participants at only one point in time. So we do not see them multiple times, or we do not do follow-ups. We only see them one point of time, and we try to compare the two studies. So what differentiates these two? So in a longitudinal study, the population stays the same while the sample is followed to see if any changes occur. In a cross-sectional study, so we consider that the population stays the same, but we consider two independent samples where one uses and the other does not use, and see if there is any change. So this is an example of a cross-sectional study. So longitudinal study and a cross-sectional study. Now in each study, notice that the one thing that changes is the sample and the design of the sample. So there are two types of sample design. So one of them is a paired sample design. The other is an independent sample design. So in a longitudinal study, we follow the paired sample design. In a cross-sectional study, we follow the independent sample design. So what are the two differences between them? In a paired sample design, we use each woman as her own control. In a cross-sectional study, that represents an independent sample design, because we take two completely different groups and we are comparing them. So the two samples are completely separate from each other and they do not have anything in common with each other. And each of them will have their separate control. So each sample will have its own control. But in a paired sample study, the sample is its own control. So the baseline is the control and the sample is the follow-up. So the follow-up becomes the sample. Now, so when are two samples said to be paired? So when do you say two samples are paired? So when each data point in the first sample is matched and is related to a unique data point in the second sample. So this is called as a paired sample. When do you call independent samples? When the data points in one sample are unrelated to the data points in the second sample, we call it an independent sample. So if they are linked, we call it a paired sample. If they are separate from each other, we call it an independent sample. So that's the difference between a paired sample design and an independent sample design. So now let's talk about the first test, the paired t-test. So paired t-tests are commonly done for longitudinal studies. So paired t-tests are more common for longitudinal studies. So what do we do in a paired t-test? So we have a baseline sample values, we have follow-up values. So for example, let's say this is baseline values and this is the follow-up values. So we calculate the difference in those values. So whatever the difference is. So in the values that we get, we take the mean difference. So we take the mean difference, so which is d bar, so which is going to be d1 plus d2 and so on plus dn by n. So this is the mean difference, d bar. And we take the standard deviation of the difference values. So we write it as SD. So SD again, the formula stays the same. So sigma di minus d bar whole square by n minus 1. So this is the formula for standard deviation of the difference. Now, so once we take the difference and the standard deviation of the difference, so we then consider the t statistic. So here t bar is written as, so let's use t, can be written as d bar divided by SD by root n, standard deviation by root n. So this is the formula for the t statistic in paid t-test. So remember that we are talking about a paid t-test. Once you have the t statistic, we then check based on the standard deviation values. So we then check the values, and here we consider two hypotheses. We have H0 and we have H1. So this t value is the test value. We also consider the alpha value as 1 minus alpha by 2. So if you consider the distribution, consider the distribution. So we have two values. So this value is t1 minus alpha by 2, and this is value is minus t1 minus alpha by 2. So these are the t values taken. So the region inside becomes the acceptance region, and the other two regions become the rejection regions. So here H0 and H1. H0 says that there is no difference between baseline and follow. H1 says that there is a significant difference between the baseline and the follow-up values. So if the t-test value if the t-test value lies between minus t1 minus alpha by 2 and t1 minus alpha by 2, we consider that we accept H0. If the t-test value is greater than t1 minus alpha by 2, or if the t-test value is less than minus t1 minus alpha by 2, we consider that we reject H0. So this is how you can do the paid t-test in any given sample. So if the t-test value lies in the acceptance region, we accept H0. If the test value lies in the rejection region, we reject H0. So this is the base understanding of the T alpha. So this method is similar to the critical value method. So in this, alpha is needed to determine the samples whether it's going to be significant difference or not. Now, if we consider the p-value method, so in the p-value method, we still use the same H0 and H1. So H0 says that there is no difference between the baseline value and the follow-up value. H1 says that there is a difference between baseline and follow-up. So here the significance level is taken on a scale of, if the p-value that we find is between 0.01 and 0.05, we consider that this is statistically significant, and if the p-value lies between 0.001 and 0.01, so we say that there is a highly significant difference. And if the p-value is less than 0.001, we say that this is very highly significant difference. So this is the scale that we're going to use to determine whether that data has a significant difference or not. Now, how to find the p-value? So p-value depends on the t-value that we have. So if you consider the p-value, so how do you find the p-value? So p-value can be taken as 2 times the probability of t less than t1 minus alpha by 2. So probability of the area to the left of t under a tn minus 1 distribution. So if we consider that this will be t n minus 1 less than or equal to t. So here this condition is when t is less than or equal to 0. P-value is 2 times the probability of tn minus 1 greater than or equal to t if t is greater than 0. What does that mean? So we'll do a problem, and it can help us understand how to calculate p-values as well. So let's consider this problem. So in this, the di values are given. So now let's use a calculator to calculate the mean of the difference. So we already told you that this is what you're going to calculate. So we want to calculate d bar. So d bar is 13 plus 3 minus 1 plus 9 plus 7 plus 7 plus 6 plus 4 minus 2 plus 2. So that gives you 48 divided by, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So answer divided by 10. So the d bar value is 4.8. Next, once you have the d bar value, we want to calculate ESD. So ESD is square root of sigma. So we want to calculate the difference between each value and the d bar value. So that becomes 13 minus 4.8. So to make it easier, let me make a small table. So I'm going to write the DI values, so which are 13, 3, minus 1, 9, 7, 6, 4, minus 2, and 2. So the d bar value is 4.8. So we want to calculate di minus d bar. So this is 13 minus 4.8. So the value is 8.2. Next is 3 minus 4.8, which is negative 3.8. So this is negative 3.8. So positive 3.8. Next you have 9 minus 4.8, which gives you 4.2. Next you have 7 minus 4.8, which gives you 2.2. Next you have 6 minus 4.8, so which is 1.2. 4 minus 4.8, which gives you negative 0.8. Next you have minus 2 minus 4.8 to minus 6.8. So you have 2 minus 4.8, so you get minus 2.8. So these are the values that we have. So now we want to square those values. So you have 8.2 square, that's 67.24, minus 1.8 square, square. So this is 7.84, so that's your final value. So next we want to find sigma of di minus d bar square. So the sum is 67.24 So try this at home. So sigma di minus d bar square. So the SD value that you get will be under root 20.844. So this will become 4.566. So you have ESD equal to 4.566 and a D bar value of 4.8. So we have the two values that we need, D bar and ESD. So here N is 10. So let's use the three values that we have now so that we can do the rest of the problem. So we have ESD, D bar and N. Now, so calculate the T statistics, or T of the test becomes D bar by ESD by root 10. So D bar is 4.8 divided by 4.566 divided by root 10. So it becomes 4.8 divided by 1.444. So it becomes 3.32. So that's the T of the test value. Now, so here they did not give us the critical value method, so they asked us to assess the significance. So let's use the T value itself as the answer. So this is the T value that you have. So notice that here the T value is greater than 0. So the probability, the P value probability becomes 2 times. Oh, I'm sorry for the mistake. It's 2 times 1 minus the probability. So how to do that? 2 times of 1 minus the probability of T greater than 3.3. So now let's use the T table. So in the T table, notice that the n value in the problem is 9. Sorry, and the n value is 10. So df becomes n minus 1. So df becomes 9. So we are looking at a df of 9, and we want to find the value 3.32. So for that, the probability. So let's look at 9. Let's look at a value of 3.32. Where does it fit? So it fits right here between 3.250 and 4.297. So here we are going to consider the two-tailed test. So the probabilities that we have is 0.01 and 0.002. Now, so here, so we are going to consider a one-tailed test. Sorry for that. We are considering a one-tailed test. So the values are 0.001 and 0.005. So now we have the values for T. So this becomes 2 times so 3.32 comes between 3.250 and 4.297. So 3.290, sorry, 3.250 and 4.297. So for 3.250, so the p-value is 0.005, and 4.297, the p-value is 0.001. So the p-value lies between 0.001 and 0.005. So remember that this is p by 2. So multiply everything with 2, so you get 0.002 less than p less than 0.00, so 0.01. So this is the p p-value that we have. Now use this p-value and look at the significance table, which one it suits. So this significance value suits the distribution 0.001 less than p less than 0.01. So now we can say that we reject H0 and we consider here that there is a highly significant difference between baseline and follow-up. So the problem here refers to the baseline value and while follow-up for all contraceptives in 10 women. So the H0 here becomes no difference, H1 becomes difference. So here the significance level of p-value is between 0.002 and 0.01. So we consider that this is highly significant difference. So between the oral contraceptive blood pressure data between 10 women between baseline and follow-up values. So that is the problem that we generate. So now try doing this problem and using the same paid t-test. So notice that here the study group contains 20 OC users, so 20 becomes N, and in the study group they have found that the mean difference DE is 4 months, so this value is D bar, and the standard deviation is 8 months, so this becomes EST. So you have D bar equal to 4, EST equal to 8, and N equal to 20. So use the data and use the p-value method and find the significance of the problem. So take a pause here, pause the video here and try solving this problem.